So today in biology we are going to talk about excretion. So what's excretion? Excretion is defined as the removal of metabolic waste from the body. It's defined as the removal of metabolic waste from the body. And this metabolic waste they include carbon dioxide, urea, uric acid, ammonia, excess water, and excess salts. And the system that is responsible for excretion in the body is referred to as the excretory system. Then the main excretory products are mainly removed through urine. So these are the points that you need to take into consideration on the introduction of excretion. So let me just write those points on the whiteboard. So I've said excretion is the removal of metabolic waste. So the removal of metabolic waste from the body and these metabolic wastes, I've said examples, we have carbon dioxide, we have urea, we have uric acid, we have ammonia, and we have excess water and salts. And the system that is responsible for excretion in the body is the excretory system. So the excretory system in the body. Then the main excretion that is removed from the body is urine. So urine is the main excretion. Now let us look at the organs of the excretory system. So the organs of the excretory system. So the organs, the first organs we have the kidney and the urinary tract. So we have the kidneys and urinary tract. In the urinary tract, they include the ureters, the urethra, and the bladder. So the urinary tract, we have the ureters, the urethra, and the bladder. Then the other organ that facilitates excretion, we have the lungs, and the other organ we have the skin. Let us look at the process of excretion. So the process of excretion is the next thing that we are going to look at. So the chemical reactions that occur in the body, they produce waste products. And if these waste products are left to accumulate in the body, this means they are going to change the internal environment of the cells. And if the internal environment of the cells are changed, the cells, they are going to die. And when cells die, this means the whole organism is going to die. So the main process that occurs during excretion is to remove the waste products, and these waste products are removed from the blood that continues to supply the body. That's the process of excretion. Then let us look at the importance of excretion. So the main importance of excretion is to remove the metabolic waste from the body. That's the main importance of excretion. If these metabolic waste are left to accumulate in the body, this means they are going to change the pH. They're going to change the pH of the cells. And if the pH of the cells is changed, this means the cells, they are going to be denatured. And when the cells are denatured, the cells are going to die and the whole organism is going to die. So the main importance of excretion is to remove the waste products. And we're going to look at some of the waste products. So we have the first waste product, which are the nitrogenous waste. So nitrogenous waste and drugs and nitrogenous waste, drugs and poisons are removed by the kidney. Then B, I have carbon dioxide, so carbon dioxide is removed from the lungs when we breathe out, and you must take into consideration that when carbon dioxide is left to accumulate in the body, carbon dioxide is going to dissolve in water that is found in blood, and when carbon dioxide dissolves in water, it's going to form carbonic acid, and the carbonic acid is going to change the pH of the cells, and when the pH of the cells are changed, the cells are going to die, and when the cells die, this means the whole organism is going to die. So carbon dioxide must be removed. Then C, I have the removal of urea. So urea is formed from excess of amino acids during the process of dimension. So this is the way diamination. So this is the process that involves the production of urea from excess of amino acids. And if urea is left to accumulate in the body, it's going to dissolve in water, and when it dissolves in water, it's going to form uric acid, and this uric acid is going to change the pH of the cells, and if the pH of the cells is changed, this means the cells are going to die and the whole organism is going to die. So urea has to be removed, and urea is removed by the kidneys through urine. So the kidneys, they are responsible for removing urea through what? Through urine. Then let us now look at, I'm going to write here D. Sorry about that, my whiteboard is full. I'm going to write the removal of excess of water. So the regulating of water levels in the blood is referred to as osmoregulation. Osmoregulation is defined as the regulating of water levels in blood. And the regulating of water levels is done by the kidneys. It's done by the kidneys where water is passed through urine. It's also done by the skin where water comes out through sweat. So this is our introduction part where we have talked about the definition, the process of excretion, and the importance of the excretion. The next thing that we are going to talk about is the kidneys. So the next thing that we are going to talk about is the urinary system. So each kidney is supplied by oxygenated blood that comes from the aorta, and the main blood vessel that supplies the kidney is referred to as the renal artery, and this blood is under high pressure, so it will go through the kidney. So when it goes through the kidney, the blood is going to be filtered by the kidney, where excess of water, salts and urea, they are going to be removed. And when these are removed, they are going to form urine. And the deoxygenated blood will move from the kidney into the renal vein. And from the renal vein, it will go back to the heart through the inferior vena cava. Then let us now look at the transportation of urine. So when urine is formed in the kidney, it will come out of the kidney through the ureters. So when it goes out through the kidney, through the ureters, it's going to be collected in a muscular bag called the bladder. And in the bladder, that's where urine is stored. Then if you want to take out that urine, it will pass through the urethra. So let me just draw the structure of the urinary system. So this is how it's drawn. So we have two kidneys. These are the two kidneys. Then I have this blood vessel. So the blood is coming here. Then I have this division. So the blood is going into the kidneys. Then I have the other blood vessel that is taking away blood from the kidneys. So the blood here is going back to the heart. So here, this part I can say this is the kidney. Then here, on top of the kidneys, we have some glands that are found here. These are referred to as the adrenal glands. Adrenal glands. So this is my kidney. So as you can see, the blood is coming through this blood vessel from the heart. So this blood vessel is referred to as the aorta. And this carries oxygenated blood. So when it reaches this division where it enters the kidney, this part and this part, this forms the renal artery. So the renal artery is the blood vessel that supplies the kidney. Then the blood vessel that takes away deoxygenated blood back to the heart is the inferior vena cava. Then the blood vessel which is here that takes away deoxygenated blood, this is referred to as the renal vein. Then after the blood has been filtered in the kidney, urine here will be produced. Then urine will be transported through these tubes. So I have this tube and this tube. So this is referred to as the ureter. Then the urine will come into this muscular bag. This is referred to as the bladder. And urine will go out of the body through the urethra. So these are the parts that form the urinary system. So I have the aorta, the inferior vena cava, the adrenal gland, I have the kidney here, I have the renal artery, I have the renal vein, I have the ureter, I have the bladder, I have the urethra. Let's now look at the internal structure of the kidney. So this internal structure of the kidney. So oxygenated blood will pass through this blood vessel. So this is the renal artery. Then I have this part. This part is referred to as the cortex. Then the part which is shaded here is referred to as the medulla. Then the inside part here is referred to as the pelvis. And after the blood has been filtered, the deoxygenated blood will go out of the kidney through this blood vessel. So this blood vessel is referred to as the renal vein. And when the blood has been filtered, urine is created, and urine goes out of the kidney through this tube, which is the ureter. In this question usually comes in paper 1, where you'll be given different points and you'll be told to name the points either for this diagram or this diagram. So it is very important to know these parts. So next time we're going to proceed on excretion. Thank you very much. So yesterday we studied the topic of excretion in biology, and we actually defined what the excretion is. We actually talked about the importance of excretion, We actually talked about the process of excretion. We also looked at the structure of the urinary system. We also looked at the internal structure of the kidney. So today we're going to proceed. We're going to talk about the structure of the nephron. So each capillary is supplied with oxygenated blood by the arteries. So the arteries, when they enter the kidney, they subdivide into the arterioles, and the arterioles, they further subdivide into the capillaries, and thousands of capillaries, they form a knot which is referred to as the glomerulus, and the glomerulus are surrounded by a cup-shaped structure which is referred to as the Bowman's capsule. So the Bowman's capsule leads to a core tubule referred to as a rhinotubule, and after several turns and cause, the rhinotubule leads to a common collecting duct, and the common collecting duct, they pass through the medulla. After passing through the medulla, they pass through the pelvis. After passing through the pelvis, they go out of the kidney through the ureter. So all these structures that I've said, these are the structures that form the nephron. So I'm going to write the points that I'm just saying. So I've said each kidney is supplied by oxygenated blood by the arteries. So the arteries supply oxygenated blood to the kidneys. Then the arteries, when they enter the kidney, they subdivide into the arterioles. So the arteries subdivide into the arterioles. Then these arterioles, they also subdivide into capillaries. Subdivide into capillaries. Then the capillaries, they form thousands of nodes. So in biology today we are going to proceed, and today we are going to look at the process of excretion in the kidney. So the process of excretion in the kidney involves ultrafiltration, which is also referred to as pressure filtration. It also involves selective reabsorption, and it also involves osmoregulation. So each glomerulus is supplied by blood by the afferent vessel. So the afferent vessel are wider than the efferent vessel that takes away blood from the glomerulus. And due to this, pressure is created. And when pressure is created, some small substances that are able to pass through the glomerulus, they pass through the walls of the glomerulus into the Bowman's capsule. And these substances, they include salts, water, glucose, and urea. And substances that are large, that are found in the blood, they don't pass through the glomerulus. And this includes the proteins such as the fibrinogens. Also the blood cells, they don't pass through the glomerulus. So the substances that pass through the glomerulus, they are referred to as the glomerular filtrate. And that process is actually referred to as ultrafiltration or pressure filtration. And some of these substances, they are still needed by the body. So they are going to travel down, and when they reach the renal tubule, that's where selective reabsorption takes place. So selective reabsorption is where the body selects the substances that it still needs. So some substances such as salts, the water molecules, and glucose, they are reabsorbed back into the bloodstream. And when reabsorption takes place, the substance that remains is referred to as urine. So urine actually includes, we have urea, water, and salts. And this urine will go through the collecting duct, and after it goes through the collecting duct, it will go out of the kidney through the ureter. And after it goes out of the ureter, it will pass through the ureter and it will collect in a muscular bag, which is referred to as the bladder. So before you passing out urine, from the body, urine is actually controlled by the sphincter muscles. So if you want to go to the toilet, you actually control the sphincter muscles to open up, and you can go to the toilet. But the sphincter muscles, they are not found in babies. That's why when the bladder for the babies is full, the urine automatically comes out. So I've actually explained the two processes. Ultrafiltration, which is also referred to as pressure filtration. I've also explained selective reabsorption. Let's now look at osmoregulation. So how does osmoregulation takes place? So osmoregulation is referred to as the regulating of water molecules in the body. So what happens if you have high water levels in the body, or what happens if you have low levels of water in the body? So if you have high water levels in the body, these are the processes that happens. So as blood passes through the brain, the hypothalamus contains the osmoreceptors. And these osmoreceptors, they are going to detect the amount of water molecules in blood. And if it is found that you have high levels of water in the blood, the hypothalamus won't make the pituitary gland secrete ADH, and the absence of ADH in the blood will cause the nephron not to be more permeable to water. So what do I mean? So during the process of selective reabsorption, I said that some water molecules are reabsorbed back into the bloodstream. So if you have high levels of water, less of water molecules are going to be reabsorbed, and this means you are going to the urine that is going to be produced, it will be dilute and in high volume. So you are going to pass out large volume of urine. So that's how the body controls high levels of water. Let us now look at how the body controls low levels of water. So the processes that occur are these processes. So as blood passes through the brain, the hypothalamus contains the osmoreceptors. So these osmoreceptors, they are going to detect the amount of water in blood. And if it is found that you have low levels of water in blood, the hypothalamus will make the pituitary gland to produce the hormone which is referred to as the antidiuretic hormone. And the antidiuretic hormone is going to diffuse into the bloodstream and to be transported to the nephron. So when it reaches the nephron, it's going to cause the nephron to be more permeable to water. So this means that during the process of selective reabsorption, much of the water molecules are going to be reabsorbed so that you can maintain the water levels in blood. And when high levels of water are reabsorbed, this means that the urine that you're going to produce is going to be concentrated and in less volume. So these are the processes that you need to take into consideration. So I'm going to draw the structure of the nephron. So the structure of the nephron looks in this way. So you have the glomerulus, So this is the structure of the nephron. Then this part is referred to as the glomerulus. Then we have this part, which is the branch from the rhino artery. Then this cup-shaped thing is referred to as the Bowman's capsule. Then the cold part here is the rhinotuber. Then the U-shaped structure is referred to as the loop of Henle. Then you have the collecting duct. Then we also have a branch from another nephron. Then this is the branch from the rhino vein. Then this is the blood capillary. So I said that the glomerulus is supplied by blood, which is the afferent vessel. So this is the afferent vessel. So this is wider than the efferent vessel. And due to this, pressure is created here, and some small particles that are able to diffuse from the glomerulus, they enter the Bowman's capsule, and these include salts, water, urea, and glucose. So these substances are referred to as the glomerular filtrate, and the process that happens here is referred to as ultrafiltration or pressure filtration. So there are some substances that are not able to pass through the glomerulus, and these include the red blood cells and the fibrinogen. So these will be transported by the blood capillary. But the glomerular filtrate will be collected in the Bowman's capsule, and it will go down, it will reach the rhinotubule. And this glomerular filtrate, there are some substances that, so if when the glomerular filtrate, they reach the rhinotubule, there are some substances that are still needed by the body, and these include some water, some salts, and glucose. Glucose is still needed by the body. So these substances will be selectively be absorbed by the bloodstream. So they'll go through the bloodstream and they'll be transported by the bloodstream this side. And this process is referred to as selective reabsorption. So what remains here now, we are going to have water, some salts, and urea. And this forms urine. So urine will flow down here through the loop of Henle. It will go there and it will go to the collecting duct. From the collecting duct, it will move out of the kidney through the ureter, and it will be stored temporarily into the bladder. So that's the process of excretion in the kidney. We shall continue next time. So today in biology we are going to proceed about the excretion, and we're going to look at kidney failure. So the kidney can stop functioning due to these reasons. So this can be due to high or low blood pressure, and the other reason can be due to intake of drugs and alcohol, and the other reason is due to the parasite called Bilharzia. The parasite called Bilharzia. So these can cause kidney failure, and there are two solutions that you can solve kidney failure, and this is a kidney machine and a kidney transplant. So when a kidney stops functioning, that means that toxic waste product, they won't be able to be removed by the body, and due to this means that a person can die due to the buildup of toxic substances. But this means that you'll be producing urine, but the urine that you'll be producing there won't be urea. Urea will just remain in the body. So I've said that there are two solutions that you can use for kidney failure. It's either you have the kidney machine or you have a kidney transplant. So the first thing that we're going to talk about is the kidney machine. So the kidney machine is also referred to as the dialysis machine, or the dialysis machine. So the kidney machine is also referred to as the dialysis machine. So we are going to look at the process of the kidney machine, the processes that occurs. So as you can see, this is the arm and we have the machine here. So as blood comes through this blood vessel, which is the artery, it's going to be transported into the kidney machine. Then we have the pump here. So the pump pushes the blood into the kidney machine. Then the kidney machine is made up of selectively permeable tubes. So these tubes, as you can see, they are selectively permeable. Then some of the things that you're supposed to know is that the diuresis fluid here, it does not contain urea. And due to the absence of urea, as blood flows through the tube, urea is going to go out of the tube into the diuresis machine, and from the diuresis machine it's going to go out of the machine. Then the diuresis fluid also contains useful substances that are contained in blood. So this means that those useful substances cannot diffuse from the blood into the diuresis fluid. Then the other question that is asked in most of the past papers, you'll be asked why this tube inside is cold. And the reason why it is cold is because the blood needs to slow down. So as the blood slows down here, that means that most of the urea is going to diffuse out of the blood into the diuresis machine. So the things that you're going to find in here, you're going to find essential salts and water. You're also going to find glucose. So this means these substances, they cannot diffuse from the tube into the diuresis machine. And after urea has diffused into the diuresis fluid, the blood will pass through this tube. It will go back into the veins, and from the veins it will be taken back to the heart. Let us now look at the kidney transplant. So what is the kidney transplant? So the kidney transplant is where a kidney is removed from the donor and is given to the recipient. So this is the surgical removal of a healthy kidney from the donor to the recipient. And before kidney transplant, the thing that the doctors they match the blood groups in the tissues. So this means the blood groups and the tissues have to be the same. But in the case where the blood groups and the tissues are not the same, the recipient immune system is going to attack the kidney of the donor. And when the kidney of the donor is attacked, that means that the kidney is going to be destroyed. But that can be prevented by matching the blood groups in the tissues. Let us now look at the advantages and disadvantages of both the kidney machine and the kidney transplant. So we are going to start with the advantages of the kidney machine. So one of the advantages of the kidney machine is that here there is no risk of death. So there is no risk of death. Then the other advantage of this is that a person does not need surgery. So you don't need surgery. Surgery is not involved. That's the other advantage. Let us now look at some of the disadvantages. One of the disadvantages is that a person that is using a kidney machine will spend a lot of hours. They spend about 8 hours in a week. So they spend a lot of hours on the machine, a lot of hours is spent on the machine. Then the other disadvantage is that here the diet has to be controlled. So diet has to be controlled. Then the other disadvantage is that it's expensive. Let us look at the advantages of kidney transplant. So one of the advantages is that here the diet does not need to be controlled. So diet does not need to be controlled. The other advantage is that when there is a successful kidney transplant, that kidney can work as a normal kidney. So that can lead to working as a normal kidney. Let us look at the disadvantages. The disadvantages is that here the drugs that are used to complement the kidney transplant, they are expensive. So drugs, there is a need of drugs. Then the other disadvantage is that a person here can die during surgery. The other disadvantage is that there are lack of donors. So the next thing that we're going to talk about is the excretion in the skin and the excretion in the lungs. So the excretion in the lungs involves the removal of carbon dioxide. And if carbon dioxide is left to accumulate in blood, it's going to react with water to form carbonic acid. And that carbonic acid is going to change the pH of cells. So that means carbon dioxide has to be removed. Let us look at excretion in the skin. So excretion in the skin involves the removal of water and small molecules of urea and salts. So when the temperature of blood increases, that means that the blood vessels that supply blood to the sweat glands, they are going to increase in size. And when they increase in size, that means a lot of sweat is going to be produced. And when a lot of sweat is going to be produced, when a lot of sweat is going to be produced, that means urea, salt and water is going to be removed from the body. Let us take into another situation where the temperature of blood is reduced. So when the temperature of blood is low, that means that the amount of blood that will be passing through the blood vessels that supply the sweat glands is not going to be increased in size, and due to this, less amount of salts, urea and water will be removed through the skin. Then the other thing that you're supposed to know about excretion in the skin is that when it's very hot, that means that a lot of sweat is produced, and when a lot of sweat is produced, that means less amount of urine will be produced by the kidney. Let us now look what happens during a cold day. So during a cold day, large amount of urine will be produced by the kidney, and less amount of sweat will be produced by the skin. So that's the process of excretion. So we are done with excretion. Where you have questions, you can ask in the group. Thank you very much.